steel tube plus hollow FRP tube as well. Then join them. So first part is concrete. Just I'm writing. You can write anything. A, B, and just name for your understanding. The first part I'm creating here because here is only one part. We may give any type of. So concrete and modeling space will be 3D model, 3D geometry. You can rotate it and see any dimension from anywhere, any angle. It must be 3D. So deformable, not rigid. Deformable means if you apply the load, it may change its shape. But rigid cannot change the shape. After the application of load, they're still in their shape. No change. So deformable is good. And the solid shell wire. Solid means fully filled. Fully filled. Just like steel bar.
Yes.
Not steel tube.
Yes, sir.
Steel tube is hollow. Okay, if you are modeling steel tube, FRP tube, that will be shell. Hollow section and including shell. If you are modeling reinforcement, that will be wire. But now we have concrete that is always solid. And further type is extrusion. Extrusion means start in 3D space and give any third dimension. That is called extrusion. Make a plane shape just like beam. Where we study in the class and on the whiteboard, the beam is plane.
This is two-dimensional.
Yes, 2 dimension. If we give its third dimension, that is called extrusion. So we have to give extrusion, means only all 3 dimensions we are giving. That's why we select extrusion, not revolution, not sweeping. Yes, and approximate size, it is just a rough estimate. You can select any size. If your sample is, you can see here the height is 400 millimeter and diameter is 200. So you can place it within this limits. That is the size of sheet that is visible. Basically, the sheet is infinite. But just like AutoCAD, which is what just give initial dimension, so that 400 is maximum dimension in either direction. So place nearby this. If you get 100, no issue. You can also make not a big issue. 500 is continue. So sheet is available with the maximum dimension of 500. Now we have to create a circular shape. The first one, circular shape with diameter 200, height 400. So if I create a circle and extrude it in the third direction, a circular cylinder will be made. So click on the circle. If you want to make any rectangular square shape, click on this. If you want elliptical shape, click here. You want any different shape. If you want to fabricate your own geometry, you can use lines as well by using coordinates. Give it coordinates, it will put the lines, match them, and extrude in third direction. Any shape can be made here. Because our case is circular for all, so we just click on circle and work in the coordinate that is more refined. By clicking on different locations, I think it's not good. So we start center from 0 to 0. Here you can see the command, enter command, XY 0 0. Enter here. Okay, 0 0. Here is the center. So if you just here, you can change the size. If you click here, the circle will be finalized here. No, I'm not clicking. I'm just giving the exact dimension. The diameter is 200, so the radius will be 100. If I put x 100, comma 0, here you can see. The radius will be 100, but diameter will be 200. Put here. It is ready. Okay, now cross here because we want to give third direction. Cross here, then done it. You will ask third dimension, extrusion. For extrusion, what is the third dimension? That is 400 millimeter. That is the length of column. So, okay. Here is the your column with diameter of 200 millimeter. If you want to rotate it, to view from different angles. Click on here. This is the icon. Yeah, shoot it here. This is the your column having height of 400 millimeter and diameter of 200. Here it is. No other part. All is 0, 0. So it is your model. Now next property. Property I will tell you later on. This is major section.
Yes, sir. Yes, sir.
Detailed, in-depth section because it requires more refined details and accurate results depend mostly on this parameter, on this module property. I will do it later on. Now assembly. There is only one part, so we will just add this one part here. No other parts will be added. I just click on assembly and here add parts, create instance. So here you can see only one part automatically has been added to assembly section. Make it independent, it is better because if there are more than one parts, then and you want to work differently on different parts, you want to mesh different for different sizes for all parts. In that case, independent option will be good. Make it independent. Means all parts should not be connected with each other. If we want to work on either part, it will allow us. If you make no dependent, all the parts must be dependent on one another, you will not be able to change to work only one parameter. You have to work for all the assembly parts at the same time. So independent is the best option. Okay, it has been added to assembly your section. Now step, just here is a create step, initial step. Okay, general static loading, not any other loading. Continue it. Here you can work on incrementation. I want to use approximately 1000 steps. I mean, if I want to apply 100 kilonewton, then and there are 1000 steps, it will the 100 kilonewton will be completed in 1000 steps. Means in 1 second there will be a load of 0.1 kilonewton. Instead, you can increase or decrease this. If you want an impact load, make it 1. So initial step and what will be the maximum step? So they must be less than 1. That will be good. Maximum increment should not be greater than 1. And these are also your assumptions. You can change them. But these are the good values to select. 0.01 for initial first step. And the maximum limit is 0.1. It should not be increased 0.1. The incrementation of load maximum will be 0.1 kilonewton. And there is a consistency of unit, of course, here. I'm working with millimeters. When you are using millimeter, the load will be in Newton.
Yes, sir.
Okay. And the stress will be in Newton per millimeter square.
Millimeters.
Of course, there will be no megapascal, there will be no kilonewton. No. Consistency of Abaqus units. Write down. You will work on this consistency. Abaqus does not know the units. If you want to give any value in any unit, then you must be consistent for yourself. Consistency of units for different systems, SI system, metric system. ये आप जाके सर्च करेंगे और देखेंगे कि अगर कौन से यूनिट में यूज कर सकता हूँ तो वो कंसिस्टेंट रहेंगे. तो टेबल में आ जाते हैं मुख्तलिफ वैल्यू गूगल करें. जैसे कि न्यूटन अगर यूज कर रहे हैं फोर्स में तो ये मिलीमीटर ही करना होगा, ये मीटर में नहीं आएंगे फिर आप गलत हो जाएगा. So after step, the next one will be interaction. Of course, there is no interaction. There is only one part. No other part is connected here. Leave it. 0, 0. Load means boundary condition. So we want to fix the bottom end and apply the load on the upper side. So I'm fixing its bottom. You can see here the bottom will be that. Here is the bottom and the top.
Yes,
I apply the load on top and I will fix the bottom. If You can see here, this is the create boundary condition. Here is displacement. I write it boundary condition 1, no. I write it fixed. Mechanical and displacement, okay. Uh, Select the location that is being fixed, bottom. You can see here the bottom has been selected. So now click on done. Yeah, make it 0, 0, 0. All rotations, all deflections will be 0, 0. Upper three are the deformations, mean displacements, and the lower three are rotation, mean movements. Movements as well as deflection are 0, 0, 0. Bottom has been fixed. Now come on to the top. You can change these boundary conditions according to your experimental cases. In experiment, mostly when we test a column, then we consider the top and bottom both are hinged, not fixed. I'm just assuming fixed.
Okay.
So both top and bottom are hinged. Hinged mean in 3D, hinged means rotations are allowed. Rotations are not zero, but deformations are zero. U1, U2, U2, U3 will be zero, but UR1, UR2 will not be zero. But I have fixed that for just simplification. I'm just giving you the information. Now apply the load. Load may be applied in the form of either kilonewton or in the form of displacement. That is stiffness method. We have not studied it, okay? But I would like to apply load by using displacement, not by using force. That give better results. That give minimum errors while running the model. So I will give